On the night of June 24, 1982, British Airways Flight 009 was executing a routine route from Malaysia to Australia, cruising comfortably at 37,000 feet. Then, without a single warning light or distress signal, all four of the plane's engines choked and died simultaneously. The flight crew checked their instruments. The weather radar was entirely clear of storm cells, and staring out the cockpit windows into the pitch-black sky revealed absolutely no visible threat. For the next 16 minutes, the heavy aircraft became an unpowered glider. It fell silently through the darkness, dropping more than 24,000 feet toward the Indian Ocean. The crew had inadvertently flown directly into a massive, dense cloud of volcanic ash. Because it was completely dry, it didn't register on the weather radar at all. To understand how a geological event can reach up and dismantle a modern machine in the stratosphere, we must look miles beneath the Earth's solid crust, where a tectonic time bomb had just detonated. Dropping down from the troposphere to the Earth's surface, the origin of this invisible cloud lies in the geological architecture of Southeast Asia. On this map, the red jagged line along the western edge marks the Sunda Trench, a massive oceanic fault line. Here, the Australian plate dives beneath the Eurasian plate, a mechanism called subduction. The extreme friction fuels a string of dangerous volcanoes along the fault. One of the direct byproducts of this tectonic collision is Mount Galunggung, a towering, forested stratovolcano in West Java. Unlike the shield volcanoes of Hawaii, which calmly ooze highly fluid, runny lava, stratovolcanoes possess an entirely different internal chemistry. The subduction zone beneath Galunggung produces highly viscous, thick magma, and that heavy consistency sets the stage for a catastrophic magmatic eruption. Deep underground, volatile gases dissolve into dense magma. As it ascends, dropping pressure causes these gases to form bubbles, a process called vesiculation. Because the magma is thick, the expanding gas cannot escape. They accumulate and press against the rock ceiling, building immense internal pressure. Eventually, the rock gives way. The sudden decompression causes the trapped gas to expand violently, instantly shattering the surrounding Earth. This chart details the Volcanic Explosivity Index, or VEI. Ranging from 0 to 8, the logarithmic scale means each step is a 10-fold increase in ejected material. Galunggung's 1982 eruption registered as a level 4, shooting an explosive column 25 kilometers into the sky. The force of the explosion pulverized solid rock and volcanic glass into microscopic, jagged fragments of ash. Driven by the heat and escaping gases, this abrasive slurry rocketed vertically, piercing the Earth's stratosphere. High-altitude winds then caught the top of the plume, carrying the invisible, glass-filled cloud 150 kilometers downwind. It settled into the exact cruising altitude and the exact flight path of British Airways Flight 009. Inside the plummeting 747, the volcanic glass had melted onto the turbine blades, starving the engines of air. But the terrifying loss of altitude actually saved the aircraft. By dropping into denser, significantly cooler air, the internal temperature of the engines dropped. The molten glass hardened and shattered, peeling off the metal turbine blades. At 12,000 feet, the crew managed to restart the engines one by one, pulling out of the glide and making a successful emergency landing at the airport in Jakarta. The danger in the sky remained entirely hidden. 3 weeks later, Singapore Airlines Flight 21A flew into the exact same lingering ash cloud, completely losing 3 of its 4 engines before limping to safety. While the planes and their passengers narrowly survived the encounter, the terrestrial environment below faced the full, unstoppable reality of a VEI-4 eruption. Down on the ground, the 1982 eruption sent massive mud flows, known as lahars, tearing through the valleys of West Java. The resulting destruction forced mass evacuations and claimed 18 lives. For Mount Galunggung, this violence was a return to form. The volcano has a long historical cycle of destruction, including a deadly 1822 blast that killed over 4,000 people, and prehistoric debris avalanches that permanently altered the surrounding landscape. The near-fatal 1982 aviation incidents transformed global flight operations. Authorities established new international safety protocols, designating volcanic ash as a critical, high-priority hazard that must be tracked across the globe. The tectonic pressure valves buried deep in the Earth's crust dictate the shape of the ground we walk on, and as the passengers of Flight 009 learned in the dark, they also rule the skies we fly in, turning the monitoring of volcanic ash into a critical, non-negotiable standard for global aviation.